Does it say it's recording? Yeah.
Mm-hmm.
All right. Okay, this is our ECE513 final project, the heart rate monitoring overview. Yeah, this is our overview of our project. So the goal was to build a heart tracking application using a low-cost IoT-enabled web app for monitoring the heart rate and blood oxygen saturation level throughout the day at a physician-defined frequency. The device will periodically remind users to take their heart rate and blood oxygen measurements and transmit these to our web application where the data can be viewed. So I'm Cameron. Thomas is in our group, could not make it for the demo. And then Joy is here with us. So first thing to point out is this is our homepage. In the URL, you can see that we have implemented using HTTPS. The browser shows that it's not secure because the certificate is self-signed. So this could be resolved if we used a trusted CA to develop our key and certificate, but we chose not to for the purpose of this project. So we have all of our main functionalities here on the homepage, like patient sign up, physician sign up, login, and then the account pages. So first we'll start with the patient sign up page. So in here, you'll enter your name, a password. So while it's running on the server, the button isn't working. But if we go to our local host, we can enter in a password that's too short. It'll display, must be 8 characters long. So if you enter a correct password, you'll sign up, an account's created, and you'll be directed to the login page. So the login page does work on the server, so I'll log in here. Yeah, so then when you log in, you get directed to the patient account page where you can select physician, view your heart rate data and the weekly summary. So we'll start with looking at our heart rate data. So here's what the data will look like when it gets sent from the device. So we have our BPM up top and then our blood oxygen below. So that gets updated every time the webhook sends it. And then the weekly summary will show the minimum, the maximum, and the average. So we can get back to the main patient account page by clicking up here. Go to select a physician. Ignore that. So we can select our physician. So you can select me and then enter the patient's first and last name there. And you can also register a device by entering the device ID. So we'll log out of there and go to the physician side. So the login for the physician is pretty much the same. enter your email, password, and then create an account that way. So you can sign up as a physician. And if you enter in the wrong stuff for the login, it'll show this error. And you log in correctly, you can view all the patients in the system. So right now we have Cameron and Twice with 2 different emails. And you can see their physician and their devices. So log out of there. Yeah, that's it. So now we'll move into how we implemented these. Joy, do you want to take over there?
Yeah. See if I can.
Do you want me to stop sharing?
Yes, please. Okay. Can you see my screen?
Yeah.
Okay, so first we can start off with the models, and here's our device schema holding all of this information for the patient email, so that way it can connect knowing which patient it belongs to, the device name that the patient enters, the device ID, and then the API that API key that we generate. And then here's all of the data related to the device. Here's the patient schema with their first, last name, everything that they entered. And then for their password, we hash it with a function in later on, but that's what we store it as to make it more clear. Here's the physician if they choose to have a physician view their information. Right now, it's currently stored as a string. And then we also have a list of devices. Right now, it's also currently listed as a string. And then here's the physician schema. We have all of the information that the physician enters when they create their account, along just to make it clear that we hold their password, their hash password, and not actually the password that they enter, and a list of patients. Here are the images that we have, just pictures of us, and then a 401 page for um, like errors in the future. Here to go through all of our JavaScript. So here we have the function to log. Oh, here are the buttons or things that we can click on the page, on the HTML page, that relate to certain functions listed out here. So if a patient chooses to log out, this is the function that's called. If the patient wants to view all of the physicians, then this is the function that gets called. Here's adding a physician. This is if there's nothing entered in the text boxes, and these are the errors that show up. Same thing here for removing a physician, adding a device, and then here's our API generation, API key generation. And then this is specifically for the login for the patient. And then this is also specifically for the patient for them when they sign up. And you can see this is the requirement that we have to have a strong password. And this is the requirement we have to make sure that they enter a valid email. And then similarly, this is going to be for the physician side. Here's a logout. Here's reading out all of the physicians for debugging, and then here's all of the patients. Same thing for logging in. We have a password that they enter, and then we have all of the requirements needed for a strong password, an email when creating an account. And then here are some styling sheets that we have. And then here to go into each web page, we have the daily view of the information. This is just to display the image if there's a potential error. This was the home page that Cameron showed you earlier with all the different options listed out here. All right, and then here we get into the patient account. So we had a navigation bar which had all of these as options where you can add a physician, add a device, view your data as a daily or weekly view, and then finally a logout button. And then the rest of it here is just our headers, our footnote, and then like our headers up here. All right, and then to get into adding a device, here's all of the text boxes that are needed to add a device. Here's the text boxes needed to log in. Oh, and here's a button to start that process to call the functions that's in JavaScript. And then here's all the text fields for physician. Here are the buttons to add and remove physicians. Similarly, here's the sign up text boxes. And then here's the bar because you can only view physicians and go back to the home page for the physician and then a log out button. All right, and then here we have all the text fields to log in for the physician, text fields for signing up, and then here's our HTML of the description of our project, descriptions of us, and where we display all of our images. And then here's the weekly summary for the data.
If you could go back to the daily view one, Joey. Yeah, I'm gonna scroll down. So for our daily view, this is where we show the charts and for all the data. So we implemented that by using a fetch statement to send our GET request to the server, and then take the response and parse it into a JavaScript object. We had to do this because the response is just a JSON object and we can't do much with that, so we had to parse it. And then we get the values by using object values. So that's how we get the data there. And then we implement our chart with chart.js. And then that's just kind of how we set up the chart there. We just put values 5, that's the field with all the BPM. And then if you scroll down, yeah, and values 4 is our blood oxygen. So yeah, good there.
Awesome. And then here we get into the routes. This is how we get our data and send it back to our front end, basically relating everything together. All right, so here's the particle routes. Did you want to get into this?
Yeah, so this is how we're getting our data from our webhook. So our webhook calls the route particle/report. So that's this one here. So when we receive that post request, we first validate that the API key is valid and matches, or that it's not empty. Then we also validate the device ID. If you could just scroll down. Yeah, we validate the device ID and make sure there's something in there, and then validate the data. So we want to make sure that's not blank or if it's undefined. We don't want to post that to the database. And then we also want to make sure that the data is a positive integer because it can't have a negative BPM or SPO2. So then once it goes through all the validation, we try and find a device in the database that matches the device ID in the request. And then if there is no device, it creates a new one. So it saves a new device there with our device ID, API key, the BPM and SPO2 from the requests. And it also gives it a timestamp with the current date and time. So that gets saved. There's some error messages that get displayed if something goes wrong. if there is a device in our database, then it will push the BPM and SPO2 data into the schema array, as well as the time. So we'll have an array of data and an array of times, and that's how they can be formatted on the chart. And then it saves that updated device. So then we also have functions for read. So it'll look so that we use that when we are trying to get the data from the device. So we'll read it from there. We can also find the data for one specific device using find and with the query device ID. And then we also have the ability to delete a device. This was mainly used for testing if we wanted to kind of reset and start from scratch.
All right, here are some of the routes for the patient. So relating back to the functions that were called in JavaScript, here's actually what happens. Here's for signing up. The patient is found, and then if the patient's not found, it will report an email or is saying that, or like it will report an error, and it will say that like, oh, the email has already been used, and then it creates a new patient with all of the information that they put into the front end. We have it temporarily saved as the doc that like it saves like an empty physician, so that way it's easier to actually add a physician instead of creating a new physician and adding it that way. And then here we have a post request for logging in where it verifies the information that's been put into the text fields from the front end, finds the patient, and then here are the error messages it if the login is failing, or specifically if the email or password is invalid. And then here is for the account authentication. So that way, when you first sign in, you can't, when you sign in, you can actually view your own page and not someone else's. It essentially takes in a token, verifies it, and then sends back the email and the last access. And then here's the route, so that way the patient can view the physicians. And then here's adding a physician. We check if the patient does exist in the database. We check if the physician exists in the database. And then finally, on the patient side, it updates that a physician has been added. And then on the physician side, it pushes a um, patient to the patient array for the physician. And then it sends notification saying like, this patient has been added to this physician's list. Then we get into removing a physician. This is very similar to earlier, but instead we're going to be, instead of finding one and updating one, we're going to be finding one and deleting one. And then for the physician, we're going to be, instead of pushing up an array or object to the array, we're going to be removing one. And then for the physician, we have the same three function routes that are in the patient, and then here we also have a view physician route. And then these are just for errors. And then here is how we actually run things. So
yeah,
yeah,
I
go ahead.
can. Yeah, so here's our app.js. So a lot of the things in this were kind of what were there by default, but we added in a couple new things. So first we added HTTPS in this stage. So we added that, and FS is for reading files. So then we added all of the routes we need, like the patient router, the physician router, and the particle router. Then we start our app with Express, and then set up our SSL server for HTTPS. So from this, we create our server, get the key from a key that we generated, and get the certificate as well that we generated with that key. We have cross-origin access enabled. Keep scrolling down. we have all the middleware that we're using. A lot of it was there by default. And then we have the middleware for our patient, physician, and particle routers implemented there, as well as something to forward the error handler, and that as well. So then we start our server by doing SSL server.listen on port 3443, and that allows us to view our web app.
And then finally here is where we actually connect our database.
Oh, I guess I can show, I'll kind of show how our device is working. So you can see it right now, it's blinking because there hasn't been a measurement in a while. So I'll put my finger on the blinking, will stop. Right now I have it set to 1 minute just for quickness in this video. So we'll wait for that to start blinking again. One problem we had with the particle device itself was getting the webhook to work properly. I can show that in a moment. So yeah, we'll just wait for this.
In the meantime, I can share the code for the particle device here in this folder.
Yeah, so I can talk
Here's all
about
the
kind
code
of
that
this
one's
code.
needed.
So the heart rate cpp.h, all that, those are our libraries that we used. We got those from SparkFun GitHub. And then in our heart rate monitor.eno, oh, there goes the light. So that was about a minute without a reading, and it started blinking. So yeah, our code for our device and hrmonitor.eno. So basically, we import all of our libraries. Right now, they're showing red because it's not in a particle environment, but we set up our particle sensor and define a lot of different variables. And then, yeah, start our variables. Here, you want to let me share? Sorry.
Yeah.
It'll just be easier. Okay, can you see that? All right, so we define and initialize all of our variables outside, and then we have these two timers that control our state machine. So the publish timer triggers every 10 seconds and was implemented so that we don't overload the particle cloud with a million like publishes. So yeah, when after 10 seconds, it moves into this publish data and changes the publish state to true. We also have a reading timer that triggers every 30 minutes, and that will trigger the LED blinking. So in our setup, we initialize our serial, initialize some pins for our LEDs, and then subscribe to our webhooks. And then we initialize the sensor, check if it's connected. If it's not communicating right, it'll display an error message. And then we initialize our particle sensor with different parameters like the brightness, how much it samples, things like that. And then we start our timers at the end of our setup. So then we'll go into the code for getting the data. So the first data we get is the SPO2 data. A lot of this code was taken from one of the examples given on the GitHub for the spark fun sensor. So that's taking a lot of samples and then doing the calculations in this function. And then it loops in here. So then this is our state machine here. So if a finger is on the sensor, the infrared value is typically greater than 50,000. So we take advantage of this to tell when the user is taking a measurement. So when their finger's on the device, we reset the reading timer. So it'll count another 30 minutes until it'll start blinking, and then we set the reading control variable to false. If it does need a reading, so if it's been 30 minutes, then it'll stay in this block of code and just blink the LED. If it's not blinking, then it'll run through here and calculate the SpO2 and the heart rate, and it'll print it out to the serial monitor. And then, yeah, we'll check for the heartbeat here. And then finally, at the end of all this, if we are in a publishing state, so if those 10 seconds have passed and our finger's on, we will publish to the particle cloud. So we do that by sending this string in JSON format of our SpO2 and then the value surrounded in quotes. So it's in JSON format, and then we publish it. If it's unsuccessful, then it'll print that, and then we change the publish state back to false, so it won't publish on the next cycle through. I think anything else that we need to go over?
No, I don't think so.
That's it. Yeah, so that's our ECE513 project. Thank you for the awesome year. We learned a lot in this, even though it was painful, but yeah, thank you.
It was fun. Thank you.